And off you go.
Yeah. Hi. Today we will talk about GraphQL, why it is awesome, and how we can make it work as a .NET developer in a microservice world. We will talk about what GraphQL is and how you can make it work in companies with multiple teams, where each team owns its own set of microservices. So who here has heard about GraphQL at all? Okay, not very many. So, and who has used it before? One person? Okay. Yeah, we will change that, and let's get started. So, who are we? I'm the co-founder of Chili Cream, and we are building the .NET GraphQL server implementation, Hot Chocolate. And also, we are building a lot of tooling around GraphQL, even for non-.NET developers. So this talk is basically for everyone who wants to get started with GraphQL on .NET, and also for developers that want to do more, since we are touching topics like building GraphQL in a microservice setup with schema stitching. But let's first start at the beginning. GraphQL was built by Facebook internally in 2012. And they put it out into the public space in 2015 as an open source specification. Facebook built GraphQL because they encountered a lot of problems with REST. So what is wrong with REST? Actually nothing, because before REST we had SOAP, and SOAP is also kind of okay, but REST just was better. It's leaner and easier to handle. We don't have those huge schemas, and yeah, the same could be said so for GraphQL. So REST is built around this concept of resources, where resources are exposed through endpoints, and I can do stuff with those endpoints. Let's say we have a person endpoint, for instance, then I could fetch a person with a get verb in HTTP, or I could change that person by putting, patching, or posting some data. So I have to deal with a lot of endpoints. So let's have a look at an example. So everybody should know Amazon, I hope, in Minsk. Anybody? Amazon? Okay. This is a product page from Amazon, and it's showing basically a MacBook here. And if we dissect this example, we basically have the product details up here, consisting of the title, the price, the manufacturer, and some other data. Also, we have the rating. So how popular is this product, and how many reviews were written about the product, or how many questions asked or answered. Moreover, we have a list of accessories that I can buy with my MacBook here. Basically all the adapters that you need to make it work. So if we fetch data for such a web page, we would maybe ask our product catalog endpoint to give us the product details. In this example, that is exactly the data I need. But in real world REST endpoints, I most of the times get more data that I don't consume. And so this request in real life would be much bigger. The second thing I would call then might be some kind of ratings API that already gives me the ratings aggregated. So I know the average rating of the product and don't have to do some calculations on my front end. Last but not least, I might have an endpoint that does product search, so I get all my related products, in this kind, my accessories. So that adds up to 3 requests just for a simple web page. But it's actually, we want it like that because we want small services and non-complicated stuff. But it's fair to say we could optimize that with REST, and we could build one optimized REST request that gives us everything at once. There are some downsides to this approach, since now we have a tailor-made request just for this specific scenario. So we can't really reuse it. And as we are turning our page into a mobile page, for instance, we need to add new functionality. Like maybe our product manager says we only want the top 2 accessories shown on our page. So then we could do that again with REST. We could add parameters. Like we could add a little toggle that switches between our mobile side and our desktop side. But the problem with that is each change in our backend has to be communicated between 2 different teams or 2 different technologies. We might have our front-end developers that then have to ask the back-end developers to change that endpoint. And as we progress further and change our API more and more, this might be problematic, since we might have applications that use the old API. And how do we get it guaranteed that that our old usage is still, our old clients are still working with this endpoint? Because we have to preserve the initial request that we published. So we could do versioning with REST, but when we start with versioning with REST, it all gets more and more complicated. So this is a typical REST request from the Amazon API. This is the most simple one that they have. And I think REST requests are just very difficult to read as long as they get. And there is actually a limit to the URI length that you have. So it's the RFC spec, I think, says 1024 characters, so you also have a limit there. And at some point, the front-end developer might also ask for documentation, and the back-end developers often look like that. So that brings us to the actual topic. Why GraphQL? GraphQL gives the power to the developer that consumes the service to ask for exactly what they want and nothing more. This avoids underfetching, where we have to fetch the data in small portions due to backend API design. Like, for instance, like in the example we saw, I have to fetch the product details, and then maybe I even need a special ID from that product from the first request to fetch the other parts of my API. And it also avoids overfetching, where I have to consume more data than I need, because that is like the REST request was designed. I can fetch everything in one request with GraphQL, and it's strongly encouraged to do that, because then the GraphQL query engine can really optimize your requests. GraphQL is strongly typed, which enables super cool tooling. I will show you a sneak peek at what is on the market. And it's simple to use, because I don't have to learn all those requests and try to generate this strange URI. Moreover, I only have one endpoint. GraphQL, you communicate with your GraphQL server through one endpoint, and you don't have to learn all the possible endpoints of a REST API. And GraphQL does away with versioning. So in GraphQL, you have the capability to easily deprecate parts of your API without breaking your consuming applications. Last but not least, documentation is built in. And since it's strongly typed, you also get some kind of documentation just by building the API. So let's have a look at the GraphQL request. So a GraphQL request, I told you that basically you specify what you want. So the GraphQL gives the power to the developer to consume what they want. So you could use an analogy here that we basically send a request to the server that looks like an empty JSON graph, and the GraphQL server just fills it up. I mean, this is an oversimplified example, and the GraphQL syntax has more operations that you can do with it. But it's a good starting point to wrap your mind around it. So, in GraphQL, the schema is at the core of every service. The schema exposes the data that I can consume and describes in the kind of data that I consume. There are three important types in GraphQL. We have the query type, which is basically everything that you can fetch from an endpoint. So you could compare that to GET request on a REST API. You then have a mutation type, which is everything that you can edit or delete. So you don't have to wrap your head around, is it a put, is it a post, is it a patch? No, it's just everything is a mutation. And last but not least, we have real-time queries. So you can basically send a query to the server and tell the server, execute that query every time something changes on my server and send me the result back. So let's see some GraphQL, I would say. And let me just get out of the demo here. Okay. So first, let's see how GraphQL really looks like. So this banana cake pop, another tool from us. So don't ask where we get these names, but my brother is very creative. So in this request, we see basically what we had in our example. I can fetch a product here, and I just specify everything that I need for that product. And when we go further, I said there's this example where we now just want the top 2 related products here. Then I can just say, okay, I don't want just all the products, but give me the first 2. And I could execute that against the backend and get a new response that only gives me there 2 related products. And since it's strongly typed and everything is an object here, I can also ask on my related products everything that I could ask on my initial product call. So I could say, give me also the price of the related product. And the GraphQL server gives me the price. So this is how powerful GraphQL is. You can really tell GraphQL what you want to consume and it will produce this. And also, if you are not happy with some kind of name here, let's say title is the defined field on the server, you can say, no, I want it to be name. And then you get it as a name. So it really is powerful for the consumer. So let's have a look at how we can build a GraphQL server in .NET, because it's super easy. So I just prepared, because this is originally a 2-hour talk, so I really had to compress it, so I pre-generated the project here. But this is a standard empty ASP.NET Core web project, and there's nothing special about it. You can see that, it's a usual startup. There's just one thing, we have the Hot Chocolate ASP.NET Core server package in there, so that gives me all the middlewares I need. And let's build some GraphQL. So I told you there are root types. And what we are building is just a simple hello world query here. So the first thing I have to do is write a query type. So I do class query. Did I write it right? And let's put a field on it. String hello. Wrong equals. And we say world. Okay, awesome. Formatted because it has to be nice. Let's go here. So the next step is we have to tell our service how it should create our schema. So we say add GraphQL import that. Oh, that's unexpected. So add query type, say just query, add that, create, and we are done. So I would do a break here, so otherwise we can't read it, and that should work. Just curious why he doesn't import the things. So I'll just build it. Did it do? Very unfortunate. Okay. Just give me a second. Okay. It's loading. Yeah, Roslyn. And now we are talking. Okay, I just imported the namespace, added the schema, and let's use GraphQL. This is basically the middleware I'm adding here. It is not reliant on MVC, so, and we're done. And fire up our GraphQL server, and it will fail because I have another server running on the same port, so we just close it, run that again, and it's done. So while that is loading, it's running now, we go back to our UI, grab the URL and fire it up. So it will load the schema, and we see the query has just our hello field. I can now just ask for the hello field and I get the word. So there was some mess up with my IDE at the beginning. Okay, but it's just that easy to build a GraphQL service. You just fill in types, create your classes, and we will figure out how to translate this to a valid GraphQL schema. You can define your GraphQL schemas schema first or code first. So let's get back into our slideshow here. So usually I would tell you more about it, but let's head on. My time is short. So now I told the whole time about that I want to have this one GraphQL schema where I can ask basically for everything. But if you think about that, that sounds kind of monolithic. So I have one endpoint consuming everything, putting everything therein. It's good for the consumer of your API, but it's actually bad if you are working with multiple teams on it. So whereas the microservice thing here. So the solution to that is something called Schema Stitching. And Schema Stitching is basically the capability to merge two schemas into one that can be executed. So you can have like multiple small GraphQL microservices all over the place, and then one gateway that merges everything together. The good thing is also, you don't have to have the server all in the same technology. You could have an Apollo server in Node.js, you can have a Hot Chocolate server in .NET, or you can have Sangria, which is Scala, or any other GraphQL server. But merging it just together is kind of not nice, because that would just, maybe the microservice API is not designed for an end user, and GraphQL Schema Stitching can completely rewrite all those microservices, and you can basically tell a Schema Stitching gateway how your API should look like, and we will rewrite it. So let's have a look at how Schema Stitching works. So this is a small setup of Schema Stitching. And we have basically 3 servers. The first server, for instance, is an Apollo GraphQL server. Let's say this GraphQL server produces the user data for our service. So it holds all the information about who's logged in, what users are there, and stuff like that. The second thing is we have a GraphQL Hot Chocolate server here on our beloved .NET platform, and that holds the main data, maybe in this example like messaging data. Think of a Twitter API, it holds all the messaging data. And then we have some arbitrary REST endpoint. But wait a minute, that is REST, that's not GraphQL. But it actually doesn't matter. We can stitch that in also. And we also can stitch in OData. And this also, so we had around for, say, that's a couple of years, and we don't want to refactor it because it works. So this holds all the statistic data. And we can stitch that all together too. GraphQL fetches all data in parallel. So when you send a request to your gateway, it will rewrite your queries. And it does that if somebody knows the Roslyn API, it does do that kind of like Roslyn does with their rewriters. Basically, we have query rewriters that rewrite the initial incoming query into a request for one of those microservices. Then fetch the data, all the data in parallel, and reintegrate it and send you the response back. Okay. So I hope that demo works better. So let's have a look at some code, because also schema stitching is quite easy. So I think I will be defensive now and just restart my thingy here. C dot. Okay. While this is recovering, okay, this is again it's just a plain empty ASP.NET Core application, but we have, instead of just the ASP.NET Core package, we also have the stitching package. That has all the rewriter logic. So, because I don't want to bore you, I pre-pasted something in here, and I will just explain it, and then we run it. So what we are doing here, first is adding via the HTTP client factory client definitions. This is basically how we can communicate with those microservices. And we opted to use the HTTP client factory because you can add things like poly to make communication more robust, so you don't have cascading service errors while you're stitching. So you could add things like retry logic, and I think you will hear about that today in another talk. So then we have a thing that is a bit different to our usual GraphQL server, because we have here add stitch schema. And we, in order to describe how to stitch something together, we have a stitching builder. And, oh, I saw just an error. So we basically tell the stitching engine to fetch all those schemas from the microservices and then stitch them together. Ooh. Just a second. Okay. So by default, we just have auto-stitching. So we apply some rules to put everything together. This might work for some scenarios, but it's not always what you want. But still, let's have a look at it. Oh, no, I don't want to run it like that. .NET run. So we run it. It's breaking because our other server is still running. Just a second. I always forget to shut off our services. So go here, back in our thing. Do it again. Yes. And it's coming up. Okay, now we have a stitched schema. Let's just refetch our endpoint here. And boom. We have now a lot of types here. And this is basically the starting example about the Amazon Shop API. So I have things like a product here, and we can look at the product, and the product has not what I would want it to have. Like it has IDs, it has related products, but where are the review APIs? So I can't really ask for the reviews here because we just auto-merged everything together. So we might have something for review here, like here's a ratings API with some counters and stuff, but that's not what my front-end guys would like to have. So in GraphQL, I can now tell the stitching engine to rewrite this schema. And this can be done by using the GraphQL Schema definition language. Let's have a look at that. So I go back to my gateway here. And in order to not annoy you with my typing, I just go here and paste it somewhere. So, and then explain it to you. So let's explain this little guy here. So I paste that into an extension GraphQL file. So in GraphQL, the schema definition language, you could describe your whole GraphQL server with that. But in GraphQL, we can extend types. It's a bit like Microsoft will introduce, I think, with C#9 or something like this. Matt Torgerson told. Basically, I could say I have a product type, but I have some more properties that I would like to put on. So I can say I have a reviews property here, or a field. In GraphQL, it's called field. And this should be of the type review. And since we have those brackets around it, it's a review list. And review should never be null. And then I have this little guy. This is called a directive. You could compare that to an attribute in C#. And this basically says the data for this comes from the review service, and call the query reviews and give it the product ID. And the product ID you will find on my type, and it's the ID field. So it's pretty easy. And you can do more with it. You can basically do deep stitchings here. Like you could ask for the ratings and then ask just for one field of the ratings. Okay, let's wire that up and see what we get if we put that in. So since this is a nice builder API, I just can go and say add extension from file. I could add it from HTTP, from string. You have lots of options here. So I just do that. Extension dot GraphQL. How was the time? Okay, I'm good. Okay, let's fire that up. Not like this. It's coming up, and we can refresh our API. And it should now change. Let's see. Product. Yeah. And now my product has a review count and a question count. And now I can basically, let's get back to our initial example I showed you about GraphQL here, because now I basically have this API, and this is now my live API that we hosted. So I'll do something else here so we'd see that it actually changes. And we fire that up. We get our third request. So that is actually the live server that we just did. We can do that with a lot of other services. We are constantly adding features here. Like we want to be able to stitch in the Microsoft Graph next, but not enough time. You can also stitch in like GitHub. We tried it because it has many types. GitHub is also based, GitHub is using a GraphQL API for people who don't know that. And they are quite happy using GraphQL. So you could stitch in GitHub as well here. Like if you want to link your data to repository data, you just add it and then it works. I think I have GitHub. Do I have GitHub? Yeah, this is This is basically GitHub. Yeah, and it fetches. So there's my repository here, Hot Chocolate GraphQL on GitHub. And I got the first 20 direct contributors here. So you could also stitch that in. So the possibilities are quite limitless. Okay, let's go back to our slides and I tell you some more. I have to optimize my slide switching workflow here. Okay, so let me give you a little bit of an outlook here. Hot Chocolate is not the only .NET implementation of GraphQL. There is GraphQL.NET, and they are at the moment still the more widely used platform. But if you want a fast GraphQL server, you should go with us. We are 13 times faster. If you listen to Conrad's talk, we basically, our Alexa doesn't allocate any memory. That's why we are so fast. And it's one of the fastest GraphQL parsers out there. There's just the reference implementation. It's slightly faster at the moment, but with the next release, we are just the fastest GraphQL parser out there. We are not even parsing GraphQL anymore on strings. We are basically parsing GraphQL on the raw memory stream that is coming in. That saves us from first converting that into string and then doing string splicing. So that makes us really, really fast. And since a lot people, we are working a lot with corporate customers. So a lot of people ask us about, can we stitch in SAP services? And not yet, but we are working on doing that. So you can stitch in your SAP services. It might not be that fast because SAP is kind of slow on that level. So where to find us? We are an open source project. We do lots of cool stuff in the GraphQL space. So you can find us on Hot Chocolate.io. There's basically all the documentation. Chili Cream, there you can find our blog there. We are blogging a lot about stuff, how to get parsers fast and how to implement efficient code. And you can also join and contribute. I invite you all, if you have spare time or you don't want to spend too much time with your wife, come over to GitHub and contribute some code. We happily invite us. We are also active on Twitter, so if you want to follow us, talk to us about GraphQL, do so. Just, we welcome everybody.
So, thank you very much. Time for questions. Questions there. And, okay, you will be the next. Who else?
Thank you. Talking about the GraphQL, I wonder if it supports any custom authorization rules, so that, let's say, I have some sensitive fields in my scheme, an object that I return, and I want them to be there, but at the same time, I don't want them to be exposed to everyone.
Yeah, we have solved this with directives, so we have authorization directives. They're based on the ASP.NET Core Policy API. So you can design very complex policies, and our resolvers will feed you in with the data and the user context, and you can then protect your API with that. So we make sure that no data that shouldn't leak out leaks out. So it's very easy. I usually show that in the demo because, but it's not enough time here to do that. But head over to the documentation. We have a lot on authorization there, and yeah.
Thanks.
So Thanks for your talk,
So,
by the way. Yeah, so there is definitely much hype around GraphQL nowadays, but I believe it's not the first attempt to solve the complexity of API by standardizing the request kind of schema. And I do remember that sometime back, like 7, 8 years, Microsoft was advertising OData as a public standard. And we actually have exposed a couple of public API in OData, and the benefit of using that was that we could query our API from Excel, from Power BI without writing any code. So do you know how wide is GraphQL adopted in terms of clients being able to call it, like client applications?
Let me give you an example here. There were, even with Facebook starting on GraphQL, there were other competing platforms when they started, like Netflix. I think Falcor was their platform, and other platforms. But now everybody rallies behind GraphQL. So Netflix is working on GraphQL, and Facebook is completely working on GraphQL now. I think they announced it 2 months ago that they are now completely GraphQL. So you can see that it really scales. And there is a problem with OData. You can't batch with OData. I talked to the Microsoft Graph developers at Build, and Microsoft is not ready to back GraphQL yet. They try to make OData better. But I think OData is too complex to use. And also, you never know what you get with OData. Does it support this? Does it support that? Is it this version or that version? And GraphQL is built on the idea about backwards compatibility. So every feature that we add to the GraphQL spec, I mean, Lee Byron is basically the head, the chief architect for GraphQL, and every feature we add in the working group is a sort for backwards compatibility, because Facebook cannot break this, because there are too many Facebook apps out there in India that might have not been updated for months, for years, sorry. So, yeah, it's much more advanced than OData, but OData has its place in the enterprise, where you want to maybe abstract some kind of database selection over HTTP.
Okay, thank you.
Okay, any questions? Then I will ask my question. So with those cool APIs in GraphQL, everyone can send a query to your server, like 100 levels of nested queries, and your server will die. Do you have any protection from that in your Hot Chocolate middleware?
Yeah. That's an excellent question, actually. That's a pro question. So yes, we have some kind that is called a cost directive. So we are associating each field with a cost. Basically, if you switch it on, we give each field a cost of 1. But it's not like that. Actually, each field has a different cost. Like if you loaded some kind of data already into your memory, to resolve each of the fields of the object is very cheap. But if you have like a paging API and you fetch 5 items, it might be a cost of 5. If you fetch 10 items, it might be a cost of 10. So our cost directive has a thing that is called multiplier, where you say, okay, this argument multiplies the cost of this field. And then you can say a query on my server has an allowed cost of 1,000. I think 1,000 is the GitHub cost allowance for one query. And then if the query is larger than that, then we don't even execute it. So GraphQL has a static query analysis. This is done before any execution is done. So we will not execute anything that violates your cost definitions. And you could even go further with that and say we have, so this user is allowed like a maximum cost of query that is 1,000, let's say that, but in an hour he's not allowed to go over 50,000. So you can do that. We have everything in place for that.
That's cool. Thank you again. Ladies and gentlemen, now very little break. In 5 minutes we will have another talk right here.